everyone, welcome back to my channel EduVibe. In today's lesson, we start with the next unit of the grade 11 chemistry, which is the matter as solutions, acids and bases. First, we start with the solutions, the matter as a solution, and then we do with the acids and bases. And this is the unit where we learn acids and bases very deep. And this chapter is continue in the grade 12 math, in grade 12 chemistry too. So today's topic is solution as a form of matter. So how the solution is the matter is in the form. So this the classification of matter you all done in the grade 10, but we like just review of this topic that matter is divided into two parts. We have a pure substances and we have mixtures. Pure substances have the constant composition. They have a constant, they have only the same substance in all that substance. Mixtures, we have a variable composition. We have some other substances too which are made that mixture, and we have other matters too. Pure substances are divided into the compounds and the elements. Compounds are decomposed by the heat and electricity, but elements are not like decomposed by heat and electricity. Mixtures are of two types, homogeneous and we have the heterogeneous. Homogeneous have the same properties throughout the mixture, throughout the thing. They have the same properties, but the heterogeneous have different properties in small samples. If we add some other, if we have one mixture and we have another mixture, they will sometimes change the properties in the small samples. So that's how the classification of matter works, and this all for review for the previous one. We will start with the solutions, that what is a solution and how the solution is made up of and what things they made the solution. So solutions are composed of at least one solute. Solute, we have want a solid, liquid, gas, anything else, but we want one solute for that, and the substance that is dissolved, and one solvent, solid, liquid and gas, that's the medium in which the solute is dissolved. So one solute which can then where the substance that is dissolved, and one solvent and where the solute is dissolving, that both things make the solution. Whether you can see the solute we have salt and the solvent we have water, and always stays that the solvent is always in the large amount than the solute. Solute is like a salt in less amount. We have a solvent and then we made the solution which is salt plus water. So that's how it works, and we get the solution kind how we make. Empirically, the solution is a homogeneous because it has the same properties throughout. That's why we say that the solution is a homogeneous. And theoretically, the uniform at the atomic and the molecular levels. If we talk about the atomic matter, atomic levels or molecular levels, that the solution is uniform in both cases. So that's all about the solutions part and how the solutions can be made and what things can make the solutions. Then we have some dissolved substances. When we have a dissolving thing added to that, when we dissolve something, we have some different terms to be known. So dissolving is the process in which individual entities of the solute disperse throughout the solvent. Solute entities can be dispersed when the individual entities can be of the solutes can be dissolved. They can be dispersed throughout the solvent. When this thing is happening, we get this dissolving concept is going. So this dissolving is a process in which individual solute dissolve throughout the solvent. And from their part, the dissolving leads to the another thing which is called the deassociation. Deassociation is a very important. We do the other thing with that too. We do some reactions of the deassociation. We have to know about this, that this is a separation of the ionic compound into ions. Like if you have a MgOH2 and we want to deassociate this, so this can be deassociated in the presence of the water like this, and we get the Mg2 plus because the Mg has a 2 plus charge, and we get the OH negative. Both should be in aqueous because this should be in aqueous because we're going about the solutions, and solutions are in the aqueous thing. So this whole process is the deassociation when the ionic compound into the ions can be conversion. Water is very common solvent because it has a polar molecule. We discussed that thing in the first unit of the grade 11 chemistry, that water is a solvent and it has a polar molecule. It has a positive and negative end. Water molecule will orient itself so that the positive end of the water is closest to the negative ion and the negative end is closest to the positive ion. So that's the water can be done. We don't know more about in the water thing. We have to just know about the what is deassociation and how deassociation works in different types of reactions. We discuss those reactions in further slides. One thing more, we have ionization. Ionization is a process by which an electrically neutral atom or a molecule is converted into an ion as is ionized in water. Okay, the ionization can be occurring when we have something in neutral. We have electrically neutral thing when we have, and the atom or molecule is converted to an ion. Any atom or a molecule can also be converted into the ion when we have electrically neutral charge. Basically, if we talk about the acids, they ionize in water. If you take your data sheet, the last page we have some table of the acid and bases. In that thing, the top six things, the top six are the strong acids. And you want this like data sheet, you want this whole thing for this unit. Further, I'm telling you how can we deal with that things out. So that's the top six are the strong acids. You have to know about that. The top six are strong acids and it actually can be ionized in water. We discuss that whole thing in the further lessons too. Next thing, we have two types of solutions. We have electrolyte solutions and we have a non-electrolyte solutions. What is the difference between that? So electrolytes, if the aqueous solutions conduct electricity, if anything conduct electricity, if any solution conduct electricity, so we get this is the electrolyte. But if they do not conduct electricity, so this is the non-electrolytes. Simple definition. But how you why you want this? Because you get the questions from here that which thing is electrolyte and which thing is non-electrolyte. The molecule compounds, in the molecule compounds, they are the non-electrolyte solutions, but except acids. Acids, we have a top six acids that all are the not the non-electrolyte, they are the electrolyte. Because the entities disperse as the neutral molecules, that's why the molecule compounds, every molecular substance is a electrolyte solution. What are molecular compounds? You know that we have this thing which is glucose. Convert this is in solid. When we converted this goes to the glucose but in aqueous now because we involve the water in that. They made the solution of glucose. That's how the molecular compounds was. They in the solid, after reaction they go into the aqueous thing. Ionic compounds we already discussed. These are the electrolyte solutions because it deassociates individual ions and cations. Like we have MgCl2, this is in solid. We do the deassociation of this because this is the ionic compound and it has an electrolyte solution. We get Mg2 plus aqueous and we have the Cl negative and we balance that with 2. So the reaction thing you have to know in this, that how can we balance things and how can the reaction take place in every situation we discussed here. So that's the ionic compounds. In acids, acids are again the electrolyte solutions because they ionize to form ions and hydrogen ions. So what are the hydrogen ions? Because we see that in the top systems from your table, they all are starting with H. They all involve in the H in acid. That's why we also, when we ionize this, we also ionize to form ions and the hydrogen ions. Hydrogen ions can be in positive like this in aqueous and we have NO3. So we have HNO3 which is a strong acid, so this can be ionized. In liquid, after reaction they will get H positive which is aqueous and NO3 negative which is again aqueous. Because hydrogen ions can be released, this is the main thing you have to know, that which product can be released, which thing can be released in the product side. In the bases, they are all the electrolyte solutions because it deassociates cations and hydrogen ions. In the bases 2, we are releasing the cations this time because we can use the positive things this time. You know that ions are the negative and cations are the positive thing. You know that. Like we have over there LiOH. This is a very strong base in solid. So we separate the Li positive and OH negative because in bases we are taking care of the OH, which are the hydroxide ions. In the acids we're taking care of the hydrogen ions. So that's the main difference, and we discuss the main difference further on lessons 2 to take care more in this topic when we do the acids and bases. And they react with the water to produce hydrogen ions too. If they react with water, they also releases the hydroxide ions. So that's all the 4 things we have to know for the solutions we discuss in today's lesson. This is very important thing and you have to know this. Let's do some example. So deassociation equation we have to make to illustrate the behavior of the sodium sulfate in water. So in your data booklet, in your data sheet, you know how to make the things together, like how to make the chemical formula. So sodium is Na positive, you know that it's a charge of positive, and sulfate is a polyatomic particle. You can see the small chart on your periodic table, that the sulfate thing. So the sulfate is SO4 3 negative, SO4 2 negative. This is 2 negative. So this is a polyatomic thing, and sulfate is SO4 2 negative. And when you combine this, you get Na2SO4, which is in solid, because this is in solid. Okay. So now you have to do the reaction. When you do the reaction, in the arrow upward, you have to write the water in liquid. So this is the ionic compound, and in ionic compound you have to separate the ions in that. So you get Na positive aqueous plus SO4 2 negative aqueous, and you have to balance this to that 2. So do you know that these things can be made this thing, and when we deassociate this, you get this and this, again these two things. So simple things. The balancing is very important. Don't forget to balance, because this is 2, you have to write the 2 in this to balance the product and reactant. So you know how to balance this. Then we have made the ionization equation. Now we have to make the ionization equation, not like different, but it is in then with that they are taking the word ionization. So we're taking care of the hydroxide ions or the hydrogen ions, that the behavior of the HBr in water. So you can see the chart of acids, the top sets you have HBr. So if HBr in the top sets, you can ionize this. If not, so you can't ionize this. So that they have the weak acids. So they have some different concept we discussed in the last few lessons of this chapter. But for now, this is a strong acid, and you have to be ionize this, but you have to release the hydrogen ions, which is H positive plus Br negative. Make sure you have to know this, that which sign, which like cation or anion the Br have. Is this a cation or anion? In this this is the ion in that case. So you have to know this thing. And we have released 2 products. That thing you have to know, and again the balancing important. Here the 1 and 1. So that's all the sorted. So this is how the ionization and the deassociation works, and we do more examples in when we do in the practice questions. The last topic, with how the process of dissolving can be happen. There is some steps. There are 3 steps. First step is that the bonds between the particles in a solute break. The solute, if we take a salt, like if you take NaCl, which is salt, firstly the particles of the NaCl, which is a solute, can be break. The process is always endothermic, because they releasing the energy, and they endothermic process. Done. They produce the energy. Yeah. The sum of the intermolecular forces between the particles in a solvent also breaks. So now the intermolecular force in the particles can also be break in the solvent, which is water. We can take in that case. We get H2 in that case. Then intermolecular forces, we discussed already in the first chapter. And this process also the endothermic. Again, the endothermic process. At the last, the attraction between the particles of the solute, which are breaking, and the particles of the solvent, resulting in the formation of the new chemical bonds. So these can be released into the new chemical bonds, and we made the 2 chemical bonds in that case, which can be like the new dissolving can be attained, and that time the energy can be released, the heat can be released. That's why it's the exothermic at the end. So the first 2 steps are endothermic, and last step is exothermic. You see the visual over there. We have some solvent, we have some solute. They doing the things. The solvent can be separated, they break the particles, and after that they made the one solution, which is a new chemical bond after the dissolving. In this whole thing, they're doing the endothermic thing. In this, they're doing the exothermic. You have to know this. You have to know these 3 steps. So that's all you have to discuss in the solutions part. The solutions part is easy somewhat, because we're starting, and this is the introduction of this. And we use a deassociation ionization in the further lessons too. In the next lesson, we more focus on the solubility. Now we're doing the solution. Now when we put something in that, so what's the solubility of that thing? That's all thing we discuss in the next lesson. That's all for this lesson. So let me swear to I learn smart not harder. Please like and subscribe to my channel. If any questions, let me in the comment section. See you in the next lesson. Till I stay with Edu. Bye.